Hello, everyone. Welcome to this lecture, to this new lecture of computer system security. This is our lecture number 4, and in this lecture, we are going to open a new chapter, and we're going to talk about authentication and access control. These two are technically two different things, but the ideas and the applications sometimes are similar, so that's I decided to put them in a kind of in the same lecture. So that's why we say authentication and access control. Okay, let's get started and first define the authentication. Of course, in the first part of this lecture, we will be talking about authentication and methods that we know for authentication, and then we switch to access control. Uh, in this slide, I'm going to introduce the problem of authentication and define it. Of course, we start from some references, like, for example, uh, National Institute of Technology, Standard and Technology. They have, in one of their documents, they have defined authentication, and this is their definition. They said the process of establishing confidence in users' identities that are presented electronically to an information system. It means that here is a kind of key point is about the uh, confidence, or establishing a confidence. You are sure that you have a server, you own a server, you own a server, and that server is supposed to give services remotely to other users that they connect to your web server or whatever server it is. And you want to make sure that person A or client A that has mentioned or has declared that he or she is client A, you want to make sure that he in this system is really client A. So we are here talking about establishing confidence in users' identities. So why do we need authentication? Basically, systems use authentication or need authentication in order to determine if some of the individuals or users are authorized to perform some particular functions. For example, you have a database in your server, and that database has some information. Some of the users are allowed to make changes on that database, and some of the other users are not allowed. So that's fine. You need to be able to authenticate them. You need to make sure that, yes, this is user A, this is client A, and he or she is allowed to make some changes into system. So let's update the database. Or it might be updating the database. It might be even reading from that database. The database might have some sensitive information, and you don't want to disclose it to everybody. It's only a few number of users are allowed to read that database. So for any type of database transaction, we may need to make sure that the right person or right individual or right client is doing that. That function may be creating a process. And I'm kind of intentionally made these two examples. Creating a process. You have a computer, and there is of course an operating system, and there are some processes running, process 1, process 2, and so on. And one user tries to generate a new process. For example, let's say process 17. So creating a process is something that some users are allowed to do and some are not. And here the person who wants to make this decision, of course, is not over network. We are talking about an operating system. We are talking about a local computer. So like I said, I intentionally made these two examples, and I'm going to talk about them later. Or another function that we may need to kind of make sure that who is doing that function and is he or she allowed to do that or not, is allocating memory. These are, of course, some examples. We may expand this list for many other functions and functionalities. Allocating memory. Again, you have a computer and there are some memory in that computer, which I'm talking about main memory. And that main memory, the bigger memory a process gets, the faster that process will be run. So it's a kind of an asset for processes to get bigger portion of memory. So memory allocation is something important. And some of the processes they would like to get a bigger portion of memory. So they may uh, want to kind of allocate or get a bigger portion of memory. That allocation is something important and something that should only be done by allowed individuals. And lastly, um, we can talk about yeah. And lastly, we can talk about the. I'm sorry, give me a second. I'm gonna take this pen. Yeah. Like I said, yeah, there are many examples that we can talk about them. And lastly, about authentication, uh, we should consider that the authorization or the authorized function or the kind of the process of the authentication can take place on a local system, like this example, for example, here, creating a processes. This is gonna happen on a local system, or it can be kind of on a remote computer across a network, like a database transaction over the internet or something. So this is a network-based authentication. So the authentication is the process of establishing confidence in order to give permission to some or one individual to perform some particular functions that might be uh, performed. The functions might be performed either locally or somewhere else over the network. Okay, so in the continuation, based on again following the NOSC um, kind of definition, they have also counted a number of requirements for authentication. Two of them are kind of called basic security requirements for authentication, and the rest are called kind of drive security requirement. The first basic property is kind of defined, or security property for authentication is this. They said in order in the authentication should be able to identify information, system users, processes acting on behalf of the users or devices. So here we are also talking about identification, which is a part of authentication. Identification, which is for example, you have a database over a web server, and you want to allow some of the users to be able to use it. So for you to be able to do that, the very first step is to be able to identify different people that get connected to your server. Who is the first one? Who is the second one? So there should be some mechanisms in order to name different people, in order to identify them. And here we are not assuming that they may lie or they may say. We basically don't want to leave our system open to everybody. This is identification. So the authentication based on the NIST should be able to identify users, processes, and devices. And the reason they say users, let me count it: number one, processes number two, and devices number three, is that sometimes a user tries to access, sometimes a process tries to access on behalf of the user, and sometimes it's a device. You have a device, you have your mobile phone, smartphone, which is going to be connected somewhere, and the mobile phone is going to be authenticated. And everybody that who has that cell phone or that mobile phone will have eventually access. So they assume that the device is in the hand of the right person. So for the drive security requirements, they say uh, authentication should use multi-factors. We will be talking about multi-factor authentication for the local and network access to privileged accounts and for network access to non-privileged accounts, which means that if uh, if you have something which is privileged, which is it contains some security assets, for example, a database in your local computer, you have a database in your hard disk, which is very important, and some of the processes are allowed to access that, but some of them are not allowed. This is suppose a database, a DB, and process one, and this is local, process two to process n. Some of them are allowed to be able to use it, but some are not allowed. So you you need to somehow um, use multi-factor authentication. We will be talking about it means that you should rely on multiple factors, not only one, in order to make sure that this is the right processes. Or if the individuals are accessing something over the net, over the network, regardless if that function or that uh, item is privileged or non-privileged, regardless of that, you should be using multi-factor authentication for that. Number 4 says employ replay resistant authentication mechanisms. Replay resistance, replay is a kind of attack that basically the attacker kind of collects or captures the communication between two legit or two authentic uh, parties. For example, an individual and a server. Individual is being authenticated, and the adversary person just uh, collects the information or messages exchanged between them. And after that, after kind of terminating that session or that secure communication or that authentication, whatever it is, the adversary or the attacker tries to resend the messages. And this is called replay attack. And just by, it doesn't need to generate anything. It just sends the same thing based on the same flow that the initiator or the actual node has done. And if the system is not replay resistant, in that case, the system will be cheated and the system will be kind of broken into. This is something that we don't, of course, like it. It's against the security, and based on the NIST, any authentication um, kind of mechanism or algorithm should try to avoid it. Okay, and these are the kind of rest of the security requirement that NIST counted for authentication mechanisms. They said authentication mechanism should prevent reuse of identifiers after a defined period, disable identifiers after a defined period of inactivity. If, of course, if I'm not using the system after a defined period, I shouldn't be, the authentication should be kind of canceled out. Enforce a minimum password complexity. We will be talking about it. Why is that important? And change the characters when new passwords are created. Prohibit password reuse for a specified number of generations. Allow temporary password use for system logons with an immediate change of the password into a permanent password. Store and transmit only cryptographically protected passwords. Password shouldn't be transmitted kind of as a plain text. We'll be talking about them. And obscure feedback of authentication information. These are the features that NIST has counted for authentication mechanisms. Okay, now let's talk about the uh, generalized and simplified model of authentication. We want to basically define what would happen in the process of authentication and how different parties are getting involved in this process. The first important thing that makes a very good sense is that when we say authentication, it means that we want to know someone, we want to verify someone, and we want to certify that yes, this is the person that he or she is claiming. So that means that the users should be pre-registered in the system. So when we are talking about authentication, it is kind of something that obviously comes with authentication, that we should have some type of registration mechanism. So that's why here I mentioned that we have two main steps in authentication. The first step, or step A, is called registration. Users come and register in a system, whatever that system is, and they become subscribers. And after subscription, after making a subscription, now every time that subscriber tries to access that specific function or functionalities that we are going to offer them, there is a need for authentication, and after authentication, authorization comes. I'll also say what is authorization later in this slide. Okay, so here is the general model, and I'm going to kind of talk about first registration as the first step. And registration by itself has multiple sub-steps that I've listed them here, and I'm going to talk about them. And here is the kind of part of the model that talks or depicts the registration step. The problem, kind of basic goal, or the objective of the registration is to have some applicant successfully and trustfully registered and have them as a subscriber. And the first step in the registration actually starts with the from the subscriber side. In the very first step, the subscriber or the applicant applies to a registration authority. So for the registration, we have two parties: registration authority and the credential service provider. Credential service provider might be the actual system that we want to work with. For example, your web server or your email server. This is an actual, but we also have a registration authority. The registration authority is a trusted entity. Here is the kind of the definition and the role of RA. A registration authority is a trusted entity that establishes and certifies for the identity of an applicant to a CPS, or credential service provider. Sorry, CSP. We have cyber physical system as well, that I normally use that term a lot in my other classes. That's why I confused. Yeah, the RA tries to. This is a basic idea. I'm trying to get some credentials. Let's say, for example, from a mail server, from gmail.com, and gmail.com is supposed to provide me excuse me, is supposed to provide me with that credentials. So but when I'm trying to register, of course I claim some information. I say my name, I say my address, And of course, someone should at least match and double check if that address exists, if the address matches with the zip code, or if my name exists somewhere in order to collect some information. That person is registration authority. The registration authority certifies or makes sure that the information provided by the applicant is correct. And after RA makes sure about the initial information provided by the subscriber or by the applicant, then the RA transfer that information to the CSP, and now the CSP starts issuing the credentials. The CSP, credential service provider, start issuing some electronic credentials to the subscriber, and now the applicant, we can call him or call her subscriber. The applicant now is subscribed to the system, and applicant has some credentials. But we should kind of look more into details of the credentials mentioned. The credentials is actually a data structure. It is a data structure that binds or kind of couples the identity of the applicant. The identity comes from the RA to some token that the applicant possess. To some token that the applicant possess. So these credentials later will be used in order to verify and authenticate this specific user. So I'm going to talk about here. I have made some kind of terms that I'm going to talk about them. We have credentials. Credential is a superset of identity information and token. Identity information is your basic information. Let's say, for example, your name, your address. And the token is something that the applicant possess, that I'm going to give you some examples about the token, what are going to be, what are kind of, what items can be considered as token. I'll be talking about it. And these two together will be binded, will be coupled to each other, and they make that credential. And the credential now is enough for the authentication. So here is a step one. Applicant starts here in this figure. You see the applicant starts with the step one and gets connected to RA, and RA provide that information to the, after verifies that information and shares it with the CPS. And in step two, CPS asks for the token and those identity information, and then issues the credentials. Okay. So let's talk about token that I just mentioned to them. I said, what can be a token? A token could be an encryption key, or for example, an encrypted password, or whatever that it is something that the individual or that the user possess. After, like I said, after providing the token by the subscriber to the CSP, subscriber bind them to some other things that the CSP generates, and that's going to be the credentials, and the credentials will be saved at both sides, at the CSP and also at the subscriber. Of course, would have it, and you may save it somewhere, or you may memorize it. If it's a part of it, can be memorized. If it's, for example, password, which are going to be later used. But after this is basically the registration process. The first step, that we register an applicant, and the applicant becomes a subscriber. After we finish the registration, now the user or the subscriber later, for example, 1 hour later, 2 hours later, or 2 weeks later, he or she wants to get access to the same resources or same functionality. This process is called authentication. This is the second step that we call it authentication, which means that we want to give the same kind of functionality. We want to give the permission to the uh, subscriber to use that functionality for the second time or for the third time. At this kind of process, we call the person who wants to reuse that functionality or that resources, we call them a claimant, someone who claim for some kind of identity, and we want to make sure that the claim is correct. So the subscriber or the claimant demonstrate possession and control of the token, and in general might be credentials to be verified by the uh, by the by a component that we call it verifier. The verifier verifies the claimant's uh, kind of information and make sure that it matches with the subscriber, or at least the subscriber named by the claimant, and everything matches. If the claimant information, including token plus uh, identity information, matches the identity stored in the verifier side, which is verifier, of course, has a kind of interaction with the CSP, and verifier gets the information from the CSP. After that, the verifier issues or asserts a signal or declares uh, a signal to the relying party and tells the relying party or RP that, okay, yeah, this is right. This person who claimed, for example, he's um, Dr. Patuji, yeah, he's Dr. Patuji, right? And then at this time, authentication is done, and the RP makes decision about the level of access that RP wants to release. This is called authorization, because you might have a system. For example, in ANT, we have, let's say, Aggie Access Online. And Aggie Access Online, I log in into Aggie Access Online. I see something, some levels of resources are available to me. Some of them are not kind of accessible to me. When you as a student log in, you see something else. Some of the items I see, you don't have access to them, and vice versa. Some of the items you see, I don't have access to them. So both of us, we've been authenticated properly. Both of us are verified, because I said that I'm Dr. Patuji, and the token that I possess, I declared it to the system. So the system successfully authenticates me. You the same, but we are not supposed to get the same level of access. So the authorization level might be different for each of us. That's why we say there is a difference between authentication and authorization. Okay, I'm done with the model. I'm done with the kind of high level or simplified model of authentication, and I mentioned everything. Here are the steps. I just for just your convenience, I numbered them. I labeled them with some numbers, and here are the corresponding action that takes place in this simplified model you see. And now I'm going to talk about the token. If you remember, we said the token is something that the subscriber possess. So we have basically four types of tokens. The token might be something that individual knows. For example, a password. You think about the password, you consider a password, and that's what you use as your token. Or it might be a PIN number or the answer to some pre-arranged or predefined questions. These are all kind of examples of something that the individual knows as a token. Or a token might be something that individual possesses. For example, smart car. I'm talking about physical uh, thing or physical objects that the individual kind of does have access to them. Smart card. The smart card is a token. When you go to, for example, the Walmart and you want to purchase something, you insert your or you swipe your credit card, and that credit card itself is a works as a token, and it helps the system to authenticate you. So it might be a smart card, electronic key card, physical keys. These are all ways for or examples of um, tokens that or objects that the individual possesses them. The token might be something that the individual is some static biometric parameters of the individual. For example, fingerprint. My fingerprint is something which is always with me. So it can be seen as a token, or my retina or my face. Those are all characteristics, static characteristics, of course, biometric, static biometric characteristics, which are always with me and they never change. So they can be used as a token. And a token might be something that the individual does, that we also call them dynamic biometric parameters. For example, my voice pattern. That's something that which is being used in many systems as a token for authentication. And of course, my voice pattern or my voice pitch or the frequency of my sound, it is not always exactly the same, but the pattern is something which is unique for me. Or my handwriting, the same example. These are all different types of or different classes that can be used to have a token. Okay, now let's talk about the multi-factor authentication. Multi-factor authentication is basically something very easy. It basically means that you do, instead of one authentication, you do two authentications. One after the second one is after the first one, and the user will be eventually allowed uh, to kind of use that property, use that resource, if both authentications are successful. So here the client comes, the first protocol, first authentication protocol use one factor, one token, and of course it's a token and it's identification information and credentials. And so if the user or the client passes the first one, it goes to the second one, and now it comes the time for checking the second parameter, second authentication factor. Again, if the second one passes, also the user will be eventually allowed to use that resources. If either fails, the authentication is failed, and the user will not have the chance to use that resource that he or she is supposed to be using. It means that we are not trusting that this claimant. Okay. Another thing that we need to know about the authentication before getting into real algorithms is about the assurance level. Um, Based on NIST, they say um, authentication comes with some assurance level, which basically means the uh, degree of certainty that we have when we authenticate a user. We authenticate a user and we let the user pass, and we allow the user to use some resources or some functionalities. So, but the question is how much certain we are. Are we 100% sure that this is an authenticated, or this is a legit, this is a real individual or user that he or she was supposed to be uh, allowed to use that resource? This is a question that uh, in the community it is being referred to as authentication assurance level. And here what you see here are different kind of wording for the same thing. For example, this one says the degree of confidence in the vetting process or checking process used to establish the identity of the individual to whom the credential was issued. How much confident we are in the checking process to make sure that the identity of the individual matches the credential. Or the other one says the degree of confidence that the individual who uses the credential is the individual to whom the credential was issued, which basically means the same thing. Like I said, it means that how much we are sure about the authentication we have done. We allowed the user to go through and to use some resources, but how much confident we are about that decision we made. And basically, we define 4 levels of assurance. Level 1 is kind of the lowest level, and the reason these are important. And level 4 is the kind of the strongest level, which means that we are very highly confident, and there is a very highly confidence in the asserted identity's validity. In level 1, there is a very low or no confidence in the authentication which is done by the system. Basically, you may wonder, you may say, why these are important. Of course, we should always go with the very high level of confidence. Yes, that's right. If that's right, but I'm gonna remind you something that we covered in the previous lecture, and that was about the conditional security. We sometimes want to pay less and keep our system a little bit less secure, because that not 100% secure is still good, is still enough for us. That's why we define 4 different levels. And these 4 different levels come with 3 different levels of impact or potential impact. Based on FIPS 199, there are 3 levels of potential impacts. Once an organization authentication is kind of going wrong, you have authentication system, and individuals are supposed to be authenticated, and you fail, and your system fails in that authentication. There might be 3 levels of potential impacts. Low means that the authentication error would have some limited effect in the organization, or would have some limited lose of assets or money. Moderate and an authentication error could be expected to have a serious adverse effect on the system, which might be effect on financial effects or financial impacts, or system may shut down and some user may get some serious negative impacts. And the highest level, which is high potential impact, says an authentication error could be expected to have a severe or catastrophic adverse effect. So putting together these 3 levels of potential impacts and these 4 levels of authentication assurance, uh, we can, there is a kind of table like this that tells us the maximum potential impact for each assurance level. And the table is somehow uh, tells us that what level of mm, uh, what level of assurance we should pick. For example, here I put an example. Consider the potential for financial loss if there is some error is low. So if we fail in our authentication in this specific example, financial loss or organization liability, uh, if we lose authentication here, we are talking about an example kind of situation, uh, case situation. Let's suppose if the financial loss or organization liability in the case of failing in authentication, the impact is low. It means that it's not gonna hurt us that much. So the table says if that's the case, you don't need to go for assurance level, let's say 3 or 4. You can stay on the assurance level 1, and that's going to be enough for you. Or we can look at the table in another way as well. For example, if the financial loss of a system, if I'm using, let's say, uh, assurance level 1, the financial loss of that system or organization should be maximum low, shouldn't be more than low. If it's, for example, moderate, my cursor just stuck. If the financial loss is moderate, I should go minimum to the assurance level 2 in order to be fulfill that requirement. Yeah, this is like I said, the kind of a balance or a trade-off between the assurance level and of course the cost that we pay for the authentication and the impacts that come if the authentication fails. I think that should be enough for today, and we will be continue from the by introducing password-based authentication and some of the known attacks to password-based authentication. Thank you for attending today's class, and please use the word, let's say, authentication, all lowercase for today's attendance code. Authentication, all lowercase. Thank you all and have a great rest of the day.